Hey guys, this is a video on graphing and factoring quadratics. So let's take a step back and say we have a function like this, y equals x minus 2. And if we want to graph this function, then we can choose any x values we want and see what y value they generate. So let's go ahead and mark this off 1, 2, 3, 4, -1, -2, -3, -4. And I can just choose any number I want. Let's just pick 3 for now. So if I put 3 in, 3 is an x value. It's on the x-axis. So it goes in place of this x value. And when x is 3, then y has to be 3 minus 2, which is 1. So I have the point 3, 1. And let's go and try a couple more. When x is 4, plug in 4, plug it in here. 4 minus 2 is 2. So I get that point. When x is 0, if I plug 0 in, 0 minus 2 is -2. So when x is 0, y is -2. And when you draw them up, you have a nice straight line. Now when x is 2, if I plug in a 2, then the y value is 0. So when 2 is my input, 0 is my output. Now there is a term called a zero. Sometimes it's also called a root. And a zero or a root is a value of x that makes the equation go to 0. So for example, if I have this equation, y equals x plus 3, you ask yourself, what could I substitute here in place of x to make a 0 pop out of this? And in this case, a -3 would be a 0, because when -3 is the x value, it makes the y value be equal to 0. Let's try this one. What if you have y equals x squared minus 4? And the question is, what value of x makes a 0? And if you're thinking 2, you're absolutely right. Let's see if you can think of the other one. Good, -2. The reason why -2 works is if I plug it in, then it is -2 as a whole, so in parentheses, -2 squared. So that's -2 times -2. Negative times a negative is a positive. 4 minus 4 is 4. And when I graph this, we have this shape. And this is a nice quadratic. It's called a parabola. And you have +2 makes a 0, and -2 makes a 0. Okay, so that's the idea of a 0. It's a value of x that when put into the equation makes a 0. Now let's say you have something like this, x squared minus 7x plus 10, and you're trying to find the values of x that make a 0. So you have to, in your mind, think of a value of x and square it, and then get that same value of x and times it by -7, and then combine those and add 10, and have it somehow be 0. And you can tell this is going to be really hard to do in your head. So the way we do this is we factor it. So we're going to rewrite this now as x minus 5, x minus 2. And the reason factoring is so powerful is because it lets us see the zeros right off. And looking at this, we can say 5 is a 0 and 2 is a 0. And just for fun, let's substitute that back into the equation and see if it works. Let's try doing 5. So 5 squared minus 7 times 5 plus 10. 5 squared is 25, 7 times 5 is 35, plus 10, and that does give us 0. And you can try the same thing with 2. So once it's in factored form, you can see the zeros. Okay, now, because of that, you can graph things pretty quickly if it's like this. Let's just do that equation again, x squared minus 7x plus 10. And if we want to graph it, then we remember in factored form, this is x minus 5, x minus 2, which means that when, let's make our table, when x is 5, the y value is 0, right? Because if the 5 goes in right here, 5 minus 5 is 0, and the whole thing goes to 0. So when x is 5, the thing goes to 0, and when x is 2, same thing. When a 2 goes in those places, especially here, 2 minus 2 is 0, and 0 times whatever is here, the whole thing turns into 0. Okay, so those are our zeros. And so 2 is a 0 and 5 is a 0, so it goes to the point 2, 0. When x is 2, y is 0. When x is 5, y is 0. And because it's a quadratic, you're already familiar with the shape. It's going to be a big smiley face, like that. Okay, so that means that we can use this as kind of a shortcut in factoring really tricky things. So for example, if you had to factor something like this, x squared minus x minus 9900. And you're thinking, well, that's going to take a long time. You have to write all the factors of this and go on and on and on. You can actually just graph it. And if you graph this, you end up with, let's actually go over to Desmos and try this out. So in Desmos, we've got x squared minus x minus 9900. Oh, let me go back. 9900. And if you zoom out far enough, there we go. We've got our two roots, negative 99 and 100. So let's go back to here. So you have roots at negative 99 and positive 100. And by looking at the graph, we can think of how to factor this. So we're going to have an x, we're going to have an x. Now this is negative 99. The trick is we're going to have to write a positive 99. We'll talk about that in a second, but just remember to switch this. Positive 100, we're going to switch this to negative 100. Now why are we switching this? The reason we're switching this is because the x value of negative 99 has to generate the 0. So when x is negative 99, we put that negative 99 there in place of x. And now you see it, right? Negative 99 plus 99 is 0. And this is why the 100 also has to be a positive 100. Because when x is 100, remember, it's the x value that we're substituting here. X value we're substituting in. When the x value is 100, that makes it 0. So remember to flip those, and you're good. So this basically means if you're ever stuck trying to factor something like x squared plus 7x plus 12, and you just can't think of numbers that multiply to be 12 and add to be 7, then you can graph this, and this one, you're going to end up something like this. And then you can say to yourself, oh yeah, negative 4, negative 3, so we're going to flip those, positive 4, positive 3. And again, the reason why this works is because when x is negative 4, it makes it 0. And I can substitute that x in here too. And just for fun, let's try that out. Negative 4 squared plus 7 times negative 4 plus 12. Negative 4 squared is positive 16. 7 times negative 4 is minus 28 plus 12. And this does, in fact, create a 0. Okay, now, last thing before we close this up is just something to get you ready for dividing polynomials, which is coming up next. So let's talk about some related math facts. 12 is 4 times 3. So because of that, 12 divided by 4 is 3, and also 12 divided by 3 is 4. It turns out you can do the same thing with polynomials. Let's do x squared plus 7x plus 10. Now this has two factors, and the factors are parentheses x plus 5. We're treating this as a single number, and parentheses x plus 2. Now, the analogy holds true. Just like we can divide 12 by 4 to get 3, we can divide this by x plus 5 to get x plus 2. And we can also divide that same quadratic by x plus 2 and get x plus 5. That's just a sneak peek to get you ready for what we're going to be doing next, which is dividing polynomials. Let's have you think about this one, and we'll close it up. X squared plus 8x plus 15. What happens when we divide this by x plus 3? Well, to do that division, you have to think, well, that is going to be x plus 5, x plus 3. And the reason why is 5 plus 3 add up to 8, and 5 times 3 add up to 15. So that's how we're sure we factored it right. And then all of this over x plus 3, and these factors cancel out, and so it's x plus 5. So you can divide a quadratic, or any polynomial for that matter, by any of its factors. Okay, that's it.